In this particular problem, we're asked to write the equation of a rational function in factored form. Nice, we don't have to multiply it all out. That has a horizontal asymptote at y equals 2/3, a vertical asymptote at x equals -5/7, a whole at x equals 2, and an x and y intercept at 0, 0. That is a boatload of information. Here's what I'm thinking. First off, I'm going to go ahead and select a marker here if it lets me. Let's see here. And I'll set up an f of x equals and then a fraction line, right? It is asking for a rational function, so I do need to have function notation. And now I can get to work, okay? Now, the first thing that I'm actually going to focus on is I'm going to jump over that horizontal asymptote and go right to the vertical asymptote. So let's do this part here in pink. All right. So if a vertical asymptote is going to be at -5/7, I need to create a factor that would give me that answer when set equal to 0. There's a couple ways of doing this. You can kind of just like think about it and figure out what it's going to be, or you can set it up as, okay, well, how about this? X equals -5/7. I'm going to multiply by 7. I'm going to just basically work this thing like backwards as far as the algebra is concerned. That cancels. And now I'd add 5. I'm going to get this thing set equal to 0. So now I have 7x plus 5 equals 0. My factor would be the 7x plus 5. There we go. Now, you're welcome to look at that one and say, okay, well, I know I need to divide by 7, and how am I going to get a negative? Will that be with a positive number that's then subtracted? You can kind of work it out in your head, but some of us like to write some things down. I'm cool with writing things down. All right, next up, we have a whole at x equals 2. So let's do that one in green. Well, if there's a whole at x equals 2, that means that I'm going to have an x minus 2 as my factor, right? That one's easy to backwards engineer. And I'll have an x minus 2 up here as well because it needs to be able to cancel out, right? It needs to be able to cancel out. That's what creates the whole. And then we have an x and y intercept at 0, 0. Well, if there's an x and y intercept at 0, 0, that means that I'm going to have an x here that's left over, does not get canceled. And then I would have my numerator equal to 0. X would equal 0. I have 0, 0 as a point on this graph. All right, now the horizontal asymptote is probably the trickiest part in this one. So I want 2/3 for my horizontal asymptote. Well, first off, if I'm going to get anything but 0 or no horizontal asymptote, my degrees need to be the same. Right now, I do have a degree of 2 in the numerator, and I have a degree of 2 in the denominator. So that's all set. All right, but right now, I have this little 7 chilling in the denominator, right? I have a 7 in the denominator. So just doing this here for the y, I can't just throw a 2/3 here, because then what I'd actually have is 2 divided by 21. We don't want that, right? So what I really need to do is in order to get 2/3, I need to take into account that 7. So I'm going to multiply this by 7, which would actually give me 14/21, which is 2/3. So this number actually needs to be 14 up here, because if this were all multiplied out, then I would have 14x squared in my numerator, and I'd have 21x squared in my denominator. So we'd have 14x squared, then some stuff, over 21x squared, and some stuff. My lead coefficients are 14/21, which reduces to 2/3. That is challenging to make sure that you take into account that 7 that's existing there. Whew, man, that's a sneaky, sneaky problem. All right, but hopefully that helps. It was awesome. I liked it. You know, it's pretty dope. See you later.